So this problem, we have three tangent lines, FD, FC, and GE. And we also know something about the problem in that FC is 8 and AE is 12, AE being a radius, and so we know this is 12 and this is 12. And we need to know quite a few things. We need to know some things about tangent lines. Like, for instance, we need to know that that's going to be 8 because two tangents that meet at the same point are equidistant from the tangent points of tangency, which reveals to us that FDAC is a kite. And then similarly, we know that this length, GC, is going to be congruent to GE. And there's actually two separate ways you could go about doing this problem. And probably the best way is to recognize that if this is this length angle right here is x, then that means this angle right here is going to be 180 minus x. And the reason for that is we have this kite, and those are right angles because of the tangent line, and so those two opposite angles have to be supplementary. And if that's 180 minus x, then this angle is going to be the supplement of 180 minus x, and so you could think about it as 180 minus 180 minus x. Well, what happens there is you end up with 180 minus 180 plus x, which is just x. Again, these are right angles, and so this becomes 180 minus x. And because it's a kite, both of these are kite, and they have the exact same angles, we actually have similar polygons. And so the lengths in this of these two kites are the same, are similar to each other. So if you think about the ratio of the short side to the long side of the kite, 8 to 12, that has to be equal to the short side. Well, this is the short side. It's the one that corresponds to this 8 because it's the one that makes up the x degree angle. And so that's going to give us 12 over, and we want to find this, so we'll call it y, 12 over y. So that gives you 8y equals 144, which when you divide by 8, you get y is 16. So now we know y is going to be 16, which means this 16. Ultimately, this problem asks us to find the area of GCA. The easiest way to do that is to recognize that kite GCA is made up of two right triangles. A right triangle is just going to be 1/2 the product of the legs, and so that's just going to give me 16 times 6, which is 96, and this is 96, so the answer is 192. You could also find the lengths of the diagonals and use the formula about the lengths of the diagonals to get there as well. The other way you could have done this problem is drawn this in, and it's pretty easy to show that that's 90 degrees as long as you know that in a kite, when you draw in your diagonal, that particular diagonal, these values are the same, and then these values are the same, and so you could do x plus y equals 180 and go from there. But if not, the way we just did it here is also a very good way to go through and solve the problem. But if this is a right angle, then you have that special triangle where you got the altitude drawn to the hypotenuse of a right triangle, and you can use all those geometric mean theorems to get to the answer.